In this video, I want to introduce you to velocity vectors. Velocity vectors are a good way to represent the velocity of a motion. Let's look at the motion of the ball. When I start the animation, the ball will start moving on an H-shaped path. While the ball moves, the velocity is shown through the arrows at a couple of points. The velocity vectors show the speed and also the direction of the motion. The velocity at every instant of that motion is always straightforward tangential to the trajectory of the motion. The length of each arrow shows us the speed. The longer the arrow, the faster the motion at that point. At the instances where the motion is faster, the vectors are longer. When a motion is slower, the velocity vectors are shorter. Let's summarize the facts about velocity vectors. The length of the arrow represents the speed. The arrows should be drawn to scale. For example, 1 inch represents 2 meters per second. You can choose any scale. The direction of the arrow is the direction of the motion. Velocity vectors show us the velocity at a specific instance. Thus, they are always straight lines, and you don't know from one velocity vector alone what will happen to the motion. A velocity vector shows us a snapshot of a motion only. Here's an example for velocity 1. The label for a velocity is often v with a subscript to differentiate between different velocities. Vector labels usually get a little arrow above the symbol to indicate that it's a vector. The little arrow does not show us the direction of the motion. The direction is given through the direction of the vector arrow. If we use the scale that 1 inch represents 2 meters per second, then at the length of 4 inch, the motion moves at 8 meters per second. The direction is close to southeast. The other velocity vector is shorter. The velocity of that motion is 4 meters per second towards south.